from a chemical point of view, water is considered by some people as the simplest nutrient. And it is. If you look at chemically, it's a very simple structure. However, it can be argued that it's the most important nutrient. And the reason for this is because we can survive far longer without any type of food, but we can't last more than 2, maybe 3 days without water. You can fast for a month. You would survive. And there are cases with that. You probably suffer because you may be hungry and all that, but your body still works as long as you drink water. So if you drink water, your body will be able to maintain its functions, and we will be able to make the adjustments necessary to sustain life in the absence of food. But if you lose the water, if you don't have that constant replacement and maintenance of the water in your body, then everything breaks loose. You can't sustain life with that. So for that reason, water is considered the most relevant, the most important nutrient, because if you deprive yourself of water, you can quickly have serious complications. You won't survive. Now, how is the water distributed in our bodies? So if we take an example of a 73-kilogram man, it's like a reference man that they use, you're going to find approximately 40 liters of water distributed in the body. Now, that 40 liters of water is separated in different compartments. So approximately 60% of this, which is in this case 24 liters, is in what we call intracellular volume. So it's what really makes up the bulk of your cell. So inside of your cell, you have this water compartment, and then you have all these different structures spread throughout that water compartment. So intracellular volume, as the name says, all the water that is inside of the cell. And this includes every part of your body. Now, we also have the extracellular volume. That is, as the name says, everything that is outside of the cell. Now, when you look at outside of the cell, you cannot, and this is approximately 40% of this 40 liters, which is 16 liters. Now, how is it actually distributed outside of the cells? So we have what is called interstitial volume, which is 28%. So interstitial volume, again, as the name says, intertissues. So in between cells, you have water. So not only the cell is formed by the cell membrane, inside you have that liquid compartment, but you also need to have water surrounding it. Why? Because that allows the exchange between cells, and allows also, so when the cell releases a byproduct of metabolism, it releases it into that compartment. So the water is very important because it permeates the cells. So it allows the exchanges to occur. So that interstitial fluid is, again, distributed in between all those cells. A typical example of this is, let's say you're riding a bicycle and you fall and you scratch your knee. It's not like a big cut or big damage for you to bleed, because it just scratches the surface of your skin. At first, it looks it hurts, but you don't see blood coming out. But if you wait a little bit, you see that there is this liquid that oozes out. And this liquid is because when you scratch into the skin, you broke the skin, and that interstitial fluid starts to come out, to show up. So that is a typical example in real life, how you can actually see your interstitial fluid. Obviously, if you have a big cut, you're going to not only have the interstitial fluid coming out, but you're going to also have the blood coming out. But the blood, where is it? The blood is in what we call plasma volume. It's a different compartment because it's circulating in your blood vessels. So it's approximately 8% of this total amount of liquid that we have. And in this particular case, 3.2 liters. So your blood is made up essentially of water, and you have all these different components dissolved in water. Right? So the color of your blood that is red is because of hemoglobin. You have a pigment that actually confers that red color to your blood. But if you were to remove everything, all the red blood cells, you would have a translucent fluid, which is what your interstitial fluid is. Interstitial fluid is not red. It's when you look at it, it's very translucent. You can see through it because you have some stuff in there, but it's dissolved. Now the blood, because you have all these other components, it changes, makes it red. But it's 8%. The interstitial volume is 28%. And then we have a last compartment that is called transcellular volume. Transcellular, as the name says, it goes from one compartment to another. It travels from one compartment to another. An example of this is if you cry, you're shedding a tear, that water that is coming out is moving from one compartment to another. We call this transcellular fluid. Another example, in your gallbladder, you keep bile in it, and bile is dissolved in fluid. When you release bile from your gallbladder into your small intestine, the fluid moves from one compartment to another. We don't see that. But another example of this transcellular fluid that we can actually see is, let's say you go and exercise and you start sweating. So the temperature in your body goes up, or at least the heat that is produced tends to increase your body temperature. But your body is very good at regulating the temperature. So what it does is that it promotes vasodilation on the surface of your skin. So that vasodilation now drives the blood towards your skin. So the heat that the blood carries will be eliminated to the environment through water that you sweat. How does that water come out? It's because your blood transfers that water into your interstitial space, then it goes into the sweat glands. The sweat glands allows it to go out. So see how it's moving from one compartment to another. So it's very important because your body is very good at regulating this water components or compartments in your body. Because you don't want to, if you lose too much water, you make your blood more viscous. It's difficult to circulate. It makes it difficult for the cells to exchange material. Your body is very good at conserving the intracellular fluid, because if you lose the water inside of the cell can't function. So first, what is going to happen is a redistribution of blood through your blood, fluids, through changes in blood flow in different compartments. But if you extend the time of exercising, let's say in a hot and humid environment, you're going to keep losing water. And it's going to come to a point that your whole system is going to be compromised because you can't properly function if you disrupt too much this amount of water that you can move around to regulate many functions and many physiological mechanisms in your body. So water is divided basically in this two compartments in general. One is the intracellular, the other one is the extracellular. Now, if you can break down the extracellular in this additional three compartments. And altogether, they make up the total amount of water we have in the body. So again, you have flexibility to play with it one way or another, as some examples that I gave here, but there is a certain limit that if you lose too much water and don't replace it, then things complicate. That's why I said you can live without food because you have quite a bit of energy stored in your adipose tissue that it could keep you going for a while. But if you run out of water, then the system cannot work because those adjustments required breakdown.